Okay, so yeah, you want to figure out if you're testing for mu or if you're testing for p first. And so here it says the mean balance of all checking accounts at a bank on December 31st was $850. So this 850, what variable is that going to represent? Mu or p?
Mu. Is it mu?
Oh, people are still saying here. But yeah, so is this going to be mu or is it going to be a proportion p? Yeah, it's going to be mu. And then it says a random sample of 55 checking accounts. So what is this 55 referring to? Yeah, that's n. And so I'll start making a little list. And then n is equal to 55. And it says from this sample, the mean was $780. Yeah, proportion's always a percentage. Yeah. Or sometimes, yeah, it should always be a percentage. But so here it says the random sample gave a mean balance of $780. So what is this 780? Yeah, that's X bar. And then here you have to be very careful about how you read the sentence, and this kind of comes back to your reading skills a little bit. And so it says with a standard deviation of $230. Is that going to be talking about sigma or is that going to be talking about S?
S.
Oh, oh, hang on real quick. I don't know what just happened. That was weird. Share. Okay, can you guys see that now? Can you see it again?
Yes.
Yep.
Oh. Wait, Bianca, were you talking? Sorry, I think I had my volume all the way down. Okay, but that was very strange. I'm not sure what just happened. But anyway, so here we have to be careful about how we read this because it's not actually going to be sigma. And so what you have to kind of do is if I were to take out that statement, then what this sentence says, so here if I say, if I take out all of that, or not all of that, just up to the gave part, then it says a random sample gave a standard deviation of $230. So what would it be if you read it like that, S or sigma?
Sigma.
Because sigma is the population standard deviation, but here, notice it's sample standard deviation. And so that's when we use S, right? And so here, you really have that S is equal to $230. Does that make sense? Is everybody okay with that? Because this is probably the most confusing part for people, and this is like the mistake I see most often, is people using sigma here. And so basically, if it gives you the standard deviation in the same sentence that it gave you the sample mean without saying like population standard deviation, then it's going to be S. And so here, like, you kind of have to do what I did here. And so it really comes back to like, what is this standard deviation referring to? Is it referring to this sample or is it referring to this population? And because it follows the random sample, it's referring to the sample. Is everybody kind of okay with that? Brianna, does that make a little bit more sense? Okay. Yeah, so these are the practice problems that you should definitely practice because this is the hardest part, right? Just figuring out if this is S or sigma. And then once you have that, then it's just, okay, now which test am I going to use? But so here you have to read these things very carefully, especially when it comes to the standard deviation. But okay, so moving on. There's a few other variables that it gives us. So it says using a 1% significance level. And so what variable is that going to represent?
Alpha.
It's going to be alpha. But then it says, what if alpha is equal to 0.025? So we're just going to have to make two different conclusions, or maybe the same conclusion, but we're going to have to look at this twice, right? It's all the same up to the very end. But so what's the very, very first thing that I should always do?
The requirements.
Yeah. So the requirements here, since I'm testing mu, well, what's the very first requirement every single time?
Random sample.
Yeah, and this time I actually put the word random in there. So we're not faking this one. And then since I'm testing mu, what do I want n to be bigger than?
30.
Yeah. And so n is bigger than or equal to 30 because it's equal to 55. And so here this implies that x bar is normal, which is the real requirement that we're checking for, right? That's why we check to make sure that n is greater than or equal to 30. And then here, the second thing that we should do, and so I'm going to bring it down here. What's the second thing that I should do every time?
The null and alternative hypothesis.
Yeah, and so here, you already told me we're testing for mu. You already told me mu is equal to 850. And so in my alternative hypothesis, what sign should I have? So it says, can you conclude that the mean balance has decreased during this period?
Less than.
Yeah, less than. Oh, you know what? Oh, I know what's going on. I'm using like this trial version of this app, and it's gonna keep closing. But my iPad's gonna die, so I can't unplug it. Okay.
That's what's happening. I was getting scared.
Huh?
I thought it was my.
Okay, so yeah, it's gonna be less than, which means it's a left-tailed test, right? And so here, after we do the null and alternative hypotheses, we have to figure out a method. Are we going to use the critical value method or are we going to use the p-value method? And so which one can I use here? The critical value method, the p-value method, or both?
I used the P one. The p-value method.
Yeah, can I use the critical value method here? This is the only case where I'm actually not allowed to. So whenever you're given, so this variable right here is what's causing problems, right? So whenever you have S, you're not allowed to use the critical value method. So be very careful with that. And so part of the critical value method involves, finding Z. But when you're given S, you can't find this variable. That's the problem, right? And so instead you would find a variable called T, but you can't use that with the critical value method. Okay, but so here, the third step would be to choose a method. And so let me kind of write down what I just said. Cannot use critical region method with S, and I'll put a little star. And so here, we're going to use the p-value method. And so for the p-value method, what function in your calculator are you going to use? And so this is the one, I think I have a poll for this one. So I want to see. So go ahead and answer that poll. I'll give you guys a minute. so there's still quite a bit of confusion as to which calculator function you guys should use when. A lot of people here, so it was about a 50-50 split between z-test and t-test, and then a few people said one prop z-test. So remember, one prop z-test is only ever if you're given a proportion, and that's why it starts with prop. And so here, when you're given mu, you cannot use one prop z-test because it's going to ask for variables that you don't have, like a p-value, or not the p-value, but it's going to ask for p. Z-test, if you go and if you look at it in your calculator, it's going to ask for sigma, and I don't have sigma here. And so that's why we have to use t-test here. And so with the p-value method, you put everything into your calculator using the t-test function. And when you do that, you're going to get a p-value of 0.014. And so what this means is that, well, first I have to make my comparison to alpha equals 0.01, and then I have to make the comparison to alpha equals 0.025, right? And so the fourth step would be make a conclusion.
Sam,
Yeah.
on my calculator, when inputting the information for the t-test, it asks for SX.
Oh yeah, that's the same thing as S.
So it's just S.
Yeah, so here, yeah, this is in your calculator, that's what it's expecting is S.
Okay, thank you.
I think in the Z test, it's when it asks for sigma, it also asks for sigma X. Let me look real quick. I found my calculator. Oh no, it doesn't. Never mind, it just asks for sigma. But yeah, so in your calculator, it looks for SX. And so if you want to write that instead of little s, you totally can. That's fine. But
Okay, thank you.
You're welcome. But okay, so here, when you make a conclusion, so let's first compare to alpha equals 0.01. And so when I do this, I get that my p-value, is my p-value less than or greater than this alpha?
Isn't it basically the same thing?
They're basically equal, yeah, but that 0.014, like if I were to write out one more decimal here, that would be 0.010. And so that 0.014 makes it a little bit bigger. And so here, my p-value is bigger than alpha. And so what do I do when my p-value is bigger than alpha?
We accept.
You don't reject it?
Yeah, exactly. So remember, you're never going to accept. You always say do not reject, right? And so, and then when you make your, like, when you write out the interpretation, you would say, like, there's not enough evidence to conclude that it's equal to 850, or there is enough evidence to conclude it's less than 850. We'll write that out in a second. And so do not reject H naught. If I compare to alpha equals 0.025, then is my p-value smaller than or less than or greater than alpha?
Greater than?
No, because, yeah, so look up here, 0.014 is going to be smaller than 0.025, right? Because it's 0.01 is going to be smaller than 0.02. Does that make sense?
So 0.01 is not is smaller than 0.014.
Oh, yeah, no, you're totally right. I'm sorry. Wow, up here, I don't know what I was thinking. I think I had switched them in my head. Okay, so in either case, you're going to reject.
Okay, good. I was scared for a second. I was rethinking all math.
Yeah, me too.
One way that you can tell is if you subtract the numbers, like if you do 0.014 minus 0.025, you're going to get a negative number, and that's how you know it's negative. And so, yeah, I totally switched them. For that first one, I switched them in my head. So I'm sorry, you guys. I do that quite often. But so in either case, we're going to reject H naught.
So for the 200 for S is 230. And so how do we know when it's sigma? Is it gonna is it only sigma when we see the sigma symbol?
No, sometimes I think actually for every example, I want to say yes, it does have the sigma symbol, but it could also not give you the sigma symbol and just say population standard deviation. I want to say I've seen that like 2 out of 5 times.
Okay, and then if the sigma pops up, that's the only time we use the z-test for it?
Yes, exactly.
Okay.
And so I'm going to make a little chart down here, but now I'm confusing myself as to whether these p-values are greater than or less than alpha. I want to, so I'm pretty sure the first one should still be greater than. Because my
For the first value, is that supposed to be like 1%?
this alpha,
Yeah, the
Yeah.
alpha.
yeah, this first alpha is 1%. And so if I were to write this as a percentage, I'd get 1.4%, which means this is greater than. Right.
I have a quick question. So it
Yeah.
was the other hypothesis was if it was less than mu. And since this is greater than the 0.14 is greater than 0.01,
Mhm.
would that not be in the critical region?
Well, we're not using the critical region method. Oh, I see what you're just kind of like comparing it to the critical region method.
Mm-hmm.
Yeah, so yeah, that would basically mean if I could draw out the curve. So this is a left-tailed test. And so what this basically means is that if this is my critical region, then here's my p-value. Makes sense? So it's
Okay.
outside of my p-value, and so I'm not going to reject. But if this is my critical region of 0.025, then my p-value is here, and so that's why I'm going to reject for that second one.
Okay, I see. Thank you.
You're welcome. And so yeah, if it's better for you to like see this as percentages, because I was getting a little confused myself between all these decimals. So this is 1.4%. This one right here, let me do this in a different color. This is 1%, and that one's 2.5%. Does that make it easier to see?
Yeah.
Yeah, okay.
Yeah, so wouldn't the second one be greater than?
No, the p-value is still going to be less than this. So so I have 1.4 is greater than 1, and I have that 1.4 is less than 2.5. So yeah, this is all correct now. So yeah, in the first one, we're not going to reject. In the second one, we are going to reject. Oh. Is everybody okay with that now?
Yes.
Yeah. Okay, cool. I ran out of room for my 5th step, but if you printed these notes, then you should have the back to this, right? Like the back of this page should be blank. And so the last step would be to interpret. And so here, I think it was Diana that had brought up when you include in your interpretations, you have to say like, oh, at the 1% significance level. And so since I have 2 significance levels here, I'm gonna make one interpretation, and then I'm just gonna tack on the at the significance level we do this, and at the significance level we don't do that. And so here, I'm gonna start it out by saying that. And so at the 1% significance level, there, and so since I'm not rejecting it, I'm basically going to say there's not enough evidence to conclude that it's less than 850. And so there is not enough evidence to conclude that. And then from here, remember, I'm just going to copy the statement from, and I'll put this in pink. No, not pink, we'll do it green. I'm just going to copy this. So the mean balance of accounts, right, has decreased. And so there's not enough evidence to conclude that the mean balance of these accounts has decreased. But there is enough evidence to conclude this at the 2.5% significance level. So do you guys have any questions about this problem? Does it make more sense now?
Yes.
Yeah,
a lot more sense.
I confused the z-test and t-test.
Okay, yeah. You're not the only one. 9 people said to use the z-test, 10 people said to use the t-test, and 3 people said to use one prop z. So there's definitely still a lot of confusion about this. And I hope
I definitely did not catch the sample standard deviation when reading through this.
yeah, and so that's the trickiest part about this, is catching that sample standard deviation. So that's a good question. Somebody just asked, how do we know when to say not enough evidence and how to say when there is enough evidence? And so essentially, you're always kind of trying to say, can I say that my null hypothesis is true? Or can I say that my alternative hypothesis is true? And so if you're rejecting H naught, and so here, let's kind of take notes on this. And so rejecting H naught means that you're kind of saying, okay, my alternative hypothesis is true then. And so I'm going to say there is enough evidence to conclude, and then you would just put like H1, right? Either yes, it's gone up, or no, it's gone down, or something like that, right? If I do not reject H naught, then there is not enough evidence to conclude H1. And so you never want to say there is enough evidence that mu is equal to 850, because you're never going to accept the null hypothesis. You're testing. And so the whole point of a hypothesis test is to see if this one is true, right? If I can say this, then I can say that my null hypothesis is false. Oh, I forgot the word conclude here. Does that make sense?
Yeah.
Okay. It's kind of just for points to make sure you guys are working on this stuff. I don't think I'm actually going to grade it. And as far as grading goes, I know I'm super behind on that. There's still quizzes at the school that I need to pick up, because the grader graded them. But I don't know if I'm actually allowed to go to school anymore. I don't think I am. So I don't know what to do about those. Okay, so does everybody have this written down? I'm going to make a little like map of what you should do when you're solving these problems. And so the very first step, so here, let's do this. Procedure for hypothesis testing. And so here, the first step, so step 1, is to always figure out which variable you're dealing with. Are you dealing with mu, or are you dealing with p, right? And so this is gonna look like a concept map. If you're dealing with p, then you can kind of skip over step 2. If you're dealing with mu, then there are 2 variables that you could be given, right? So what are the options for mu? And we just kind of saw one of them, right? Here we saw S. So if you,
S and sigma.
yeah, exactly. So after you figure out that you're testing mu, you need to figure out if you're given sigma or if you're given S. So here for P, you can skip that step, right? Because there's no second variable that you have to worry about. Well, I guess here you could figure out if you're given P hat or if you're given X. If you're given P hat, you can find X. Excuse me. If you're given sigma, what function in your calculator are you going to use?
Z-test.
Yeah, you're going to use the z-test. If you're given S, which function are you going to use?
Z-test.
Yeah. And then here, the only reason I kind of wrote P hat is because once if you're given P hat, you're going to find X, which is equal to P hat times N, right? But in either of these cases, what function in your calculator are you going to use? So whenever you're testing P, what function do you use?
The
One prop Z.
Yeah. Okay, so this is super messy and not very neat, but does this kind of help see what you should do now?
yeah, it helps a lot actually.
Okay, cool.
It was hard to just like flip through the notes and kind of like piece together like
Yeah.
the different variables because each of them had like 2 that they could possibly be. And then some of like the questions were more vague than others, so that's why I was like struggling trying to figure out which test to use.
Yeah, that's probably the hardest part here. And so this is like, that's why when I'm testing for this, I really want to make sure that you guys know which test to use, because if you use the wrong one, you're going to get the whole problem wrong. And so here, I'm going to add another thing to this. So this is like calculator function. Oh, actually, these aren't even lined up properly. This step 1 doesn't make sense. But so here, if I'm given sigma, I can use both the critical region method and the p-value method. But if I'm given S, which method am I only allowed to use? What's the only method?
P-value.
Yeah. And then P is again both of them. So I'll just kind of copy this real quick. Oops. There you go. And so here, when you're doing these, if you're testing for mu and you're given sigma, if you're testing for P, you can choose either the critical region method or the p-value method if I don't specify, whichever one's you're more comfortable with. I think I'm at least once I'm going to specify though, so make sure you know both. But so are there any questions about this, about hypothesis testing at all? Because we're about to move on to chapter 7. And so if you have those 7.1 notes, that's what we're going to work on next. Are you guys done writing this? Can I change the page?
A few more seconds.
Okay, I'm gonna pause the recording then, because I feel like this is just so... We're done talking about hypothesis testing for quite some time. We are gonna come back to it, possibly towards the end of the semester, when we start talking about having 2 samples at the same time, but that's only if we have time to get to that. If we don't, then we're not gonna cover it. But so we may or may not get to hypothesis testing again. But now we're moving on to confidence intervals, which is somewhat connected to hypothesis testing, and I'll show you how, not today, but on Friday. I'm going to show you how. So today we're just going to go over some basic definitions because we don't have that much time left. But I don't have them in here because these are when we first started, I was writing my notes on paper. But I want to say if you go back to the chapter 6.5 notes, there's a box on the very first page about different types of like statistics you could do on stuff. And so one of them, remember, it was estimation, testing, and regression. Regression is that very first thing that we did. It was the correlation stuff. Testing, we just covered that. And then now we're getting to the estimation. And so here, all of these problems are going to ask you to estimate either the value of mu or the value of p. And so if we start taking these notes, then, so estimation is when we use a sample statistic. And so what's an example of a statistic again? So is mu a parameter or a statistic? Alpha is actually neither. Yeah, alpha is just the significance level. But so like for mu, would that be considered a parameter or a statistic? And remember, mu means population mean.
Parameter or statistic?
It's going to be a parameter, right? Because population parameters are things about the population. And so then the statistic that goes along with that is going to be X bar. What's the other sample statistic that we've been looking at? It's P something. S is, yeah. But S is totally another one too, right? Anything that's talking about the sample is going to be considered a statistic. But the only thing is we're just not going to, so S is a statistic, but we're not going to be estimating sigma using that, but that's okay. So here, I'm actually going to switch the order of these. And then yeah, here, so we're going to use statistics to estimate parameters like mu and p. And then here, not testing or estimating sigma. Okay. So there's some definitions that I need to tell you before we can actually start estimating these things. What we do is we start out by using something called a point estimate. And this point estimate is just the value of the sample statistic that we use to estimate the population parameter. So here would be like X bar, P hat, mu, P. So yeah, the point estimate is just going to be the sample statistic that you're given. It's just kind of like a new name for it. And so this note down here is just saying it is unlikely that the point estimate X bar or P hat is equal to, or here, since I put population mean, I can't put P hat, but it's unlikely that X bar is equal to mu, right? It's just, I think we had kind of talked about that in the beginning of the semester when we were talking about sampling distributions. If I were to take all of you guys in the class, get your average height, like get the height, like get all of your heights, find the average height for everybody in the class, it would be really unreasonable for me to say, okay, that's the average height for everybody at Cal Poly, right? And so here, that's why you want to estimate it with a range of numbers rather than just saying, okay, my sample statistic is true for everybody. Rather, what we're going to do instead is we're going to say, okay, let me take my sample statistic and find kind of like a margin of error and see, okay, if I can say, okay, it's not equal to this number, but that number could be one of a few numbers that it's equal to, right? And so what we do is we're going to take our point estimate and add and subtract a single number to it, and then there's our range of values. But so here, this example, what it's saying is that suppose the Census Bureau, oh, this is a good example. The census is due in 5 days. I don't know if you guys knew that. If you live alone, if you like don't live with your parents, you're gonna have to fill out the census by April 1st. But anyway, so suppose the Census Bureau takes a sample of 10,000 households and determines that their mean income per month is $33,516. What they can do is they can either use that to state that the average monthly income for all houses is that $3,500. But again, that's a little unreasonable. They only took a sample of 10,000 households. I want to say that that's not a lot of households for everybody in America, right? Or what they can do is they can create an interval that is centered around that 3,500, right? So this interval, this is just a range of numbers. And so what we're doing is we're estimating these parameters with ranges of numbers. And so if we do this example, it says add or subtract 50 from the average monthly income and write your answer in interval notation, plus minus notation, and inequality notation. And so in the very beginning, we had gone over interval notation, all of these different kinds of notations. So you guys should have these notes. But so here, what I'm going to do is I'm going to start with 3516, and I'm first going to subtract 50. And when I do that, I get 3466. And then I'm also going to add 50. When I do that, I get 3566. And so in interval notation, which number should I start with? So interval notation, remember when we were doing like our critical regions, if we had a left-tailed test, then we started at negative infinity and went up to like 1.6 or something, right? And so that's what I mean by interval notations, is you put the smaller number first, and then you're gonna work your way up to the second number. And so here, which one of these numbers should be the first number in my interval? 3466 or 3566?
34.
Yeah, that 3466. And so here, I'm going to use, actually here, I'm going to use these brackets instead. We're going to use parentheses instead of the square brackets. So we're going to say it can't equal this value, but it can be somewhat close to it. And so that's what my interval looks like. And so in words, what this is saying is it's saying start at 3466 and include every number until you stop at 3566. Okay, so remember that this value here, this 3516, was my value of X bar. And I'm using that to estimate mu. And so my inequality notation that's gonna look, so do you guys remember the inequality notation when we were doing this? We did it in chapter 6 quite a bit when we had like the probability that x is between 3.4 and 5.6. Do you guys remember that? Or the probability that x is greater than 3.2. This right here, this x greater than 3.2, that's inequality notation. And so here, we were using x here, or sometimes we had z if we were talking about the standard normal curve. But here, since we're estimating mu, that's what's going to be in my inequality notation. And so essentially what we're saying is we're saying mu is between 34.66 and 35.66. Oops, not parentheses. Is everybody okay with these two answers?